Okay, welcome to the third and final video on nomenclature. In this video we're going to be talking about naming acids. We're going to learn how to name binary acids and oxyacids. So first we'll learn how to name binary acids, and that's basically going to be acids without an oxygen. So remember, we're using the Brunson-Lowry definition of an acid, which basically means it's going to have an H. So if you ever see a compound with an H in front of it, it's an acid. So to name binary acids is very straightforward. There's only two rules you need to follow. The first one is the acid name always starts with hydro. That's the first rule. The second rule, the acid name is going to end with ic. So for example, earlier I drew out HCl. This is an acid because we know it's an acid because it starts with an H. It doesn't have an oxygen, so it's a binary acid, meaning that the name of this is going to be with hydro. It's going to end with ic. It's going to be hydrochloric acid. So basically all you're doing is you're using the atom that's attached to the hydrogen as the root word and changing the ending to ic. So hydrochloric acid. These two rules are going to work with any binary acid. We could replace the Cl with the Br, for example. Again, it's going to be hydro. The root word is going to be bromic. It's going to end with ic. So hydro bromic acid. And again, one last example. Hydrogen iodine. Right here, again, it's going to begin with hydro. The iodine, the ending is going to change to ic. So it's going to be hydro iodic acid. That's it for binary acids. Remember, binary acids is any acid. You know it's an acid because it begins with an H and does not have an O. Okay? So Hi, hydroiodic. It's going to begin with hydro. It's going to end with ic. So now we're going to move on to naming oxyacids. And that's going to be the acids with the oxygen in it. So this was a binary acid, hydrochloric acid. If we add an oxygen, this is now what we're going to learn how to name here. These are oxyacids because this right here, if you remember from the previous video, we talked about oxyanions. Chlorate. So, in naming oxyacids, there's a couple rules you're going to follow. First, you gotta the prefix, and the binary acid, the prefix was always hydro, and the oxyacid, the prefix follows whatever prefix that the anion had. The oxyanion had. In this case, this is just chlorate. If we were to increase the oxygen to 4, to fluor, we have perchlorate. See, now we have a prefix in front of the chlorate. That means this acid the name of this acid is going to carry along the prefix. So if it doesn't have a prefix, don't worry about it. If it has a prefix, like in this case, it carries it with it. So this acid, we're going to start naming it with per. Again, the root word is going to, whatever atom you have here, that's going to be the root word. So here we have chlorine. There's our root word. Now the ending of oxyacids, the ending is going to depend on the ending of the oxyanion. If the oxyanion ends in ate, the ending is going to end in ic. Okay, if the ending were to end in ite, as in chlorite, the ending, if it ends in ite like chlorite, the ending is going to be an os. An os. Chlorite doesn't have a prefix, so we're not going to include a prefix here. It's just going to be chlorous acid. So going back to this one, if we're to remove another oxygen from here, just having one oxygen, I'm just going to erase that there. This is now hypochlorite. Hypochlorite. And remember, whatever the oxyanion, whatever prefix it carries, when you're naming the acid, it's going to have the same prefix. So this is going to be hypochlorous acid. And that's all there is to it. So the first rule, you're going to identify the oxyanion. The next thing you're going to do is name the prefix. And the prefix is determined by whatever prefix the oxyanion has it. It's just going to carry on to naming the acid. So again, it's going to have the same prefix as the oxyanion. If the oxyanion did not have a prefix, you're not going to use a prefix. The third rule, you're just going to name the ending of it, the suffix. So when you're naming the ending of the acid, basically if the oxyanion ends in ate, the acid is going to end in ic. If the oxyanion ends in ite, the acid is going to end in os. And this is the same thing whether you have perchlorate, for example, chlorate, they both end in ate. Or if you have chlorites or hypochlorite, they both end in ite. Whichever way it ends, you're going to determine the ending of the acid. So let's do a couple more examples. So if we have something like HiO3, when naming this, First thing we're going to do is identify the oxyanion. Here's our oxyanion. It's chlorine. I'm sorry, it's iodate. It's iodate. Second thing, we're going to name the prefix. It's going to be the same prefix as the oxyanion. In this case, the iodate doesn't have a prefix. It doesn't have hypo. It doesn't have per. It's just iodate. So no prefix for the acid. The third rule, if we look here, the oxyanion ends in ate, which means the acid is going to end in ik. If it ends in ate, the acid ends in ik. If it ends in ite, the acid ends in os. So in this case, it ends in ate. So the acid is going to end in oak. It ends in ate, so the acid is going to end in ik. So here we have iodic acid. Let's just do one more. HBRO. First thing we're going to do, identify the oxyanion. HBRO, here the oxyanion is hypobromite. We know this because it's 2 less oxygens than the baseline bromate. So hypobromite. Next thing, to name the acid, we're going to name the prefix. The prefix is the same as the prefix of the oxyanion. So this acid name is going to start with hypo. In this case, rule number 3, the oxyanion ends in ite, which means the acid is going to end in os. Now we just fill in the root word, which is the bromate. There you have it. Hypobromous acid. Again, this will work with any acids you're working with as long as you're able to name the oxyanion that's attached to. And that's going to be it for